Welcome to this comprehensive guide on unit testing with Pester, the PowerShell testing framework. In this tutorial, you will learn how to write, organize, and execute tests for your PowerShell code. Testing is a critical skill that helps you catch bugs early, maintain code quality, and build confidence in your scripts. Whether you are automating system administration tasks or building complex PowerShell modules, Pester provides the tools you need to ensure your code works as expected. Let's dive in and explore the fundamentals of testing with Pester. Pester is a PowerShell testing and mocking framework that has become the industry standard for testing PowerShell code. It provides a structured way to validate that your code behaves correctly under different conditions. With Pester, you can write automated tests that verify your functions produce the expected results. This means you can run these tests repeatedly whenever you make changes to your code, giving you immediate feedback about whether something broke. Pester supports both unit testing, where you test individual functions in isolation, and integration testing, where you test how different parts of your system work together. It is built into Windows 10 and 11, though you will want to update to the latest version for the best features. To get started with Pester, you need to install it from the PowerShell gallery. Open PowerShell with administrator privileges and run the command. Install-module-name pester-force-skip publisher check. The force parameter ensures the installation proceeds even if an older version exists, and skip publisher check bypasses certificate validation. After installation, verify it worked by running get-module-name pester-list available. This displays all installed versions of Pester on your system. Keep in mind that Windows 10 and 11 come with an older version of Pester built in. You will want to install the latest version to access new features and improvements. The installation typically takes just a few moments, and once complete, you are ready to start writing tests. Pester tests follow a specific structure that makes them easy to read and organize. The fundamental building blocks are the describe and it blocks. The describe block groups related tests together and typically corresponds to a function or feature you are testing. You provide a descriptive name as a string to identify what you are testing. Inside the describe block, you use it blocks to define individual test cases. Each it block represents one specific behavior or scenario you want to verify. The name you give to an it block should clearly describe what behavior is being tested. For example, you might write, "It should add 2 numbers." Inside the it block is where you put your actual test code and assertions. This structure creates a hierarchical organization that makes your test suite easy to navigate and understand. Let's walk through a complete example of writing your first Pester test. Suppose you have a simple function called get-addition that takes 2 parameters, a and b, and returns their sum. To test this function, you create a describe block named get-addition. Inside it, you add an it block that describes the expected behavior. It should add 2 numbers. Within the it block, you call your function with test values, such as get-addition-a2-b3. You then pipe this result to the should-be assertion with the expected value of 5. This assertion checks whether the function output matches what you expect. If the function returns 5, the test passes. If it returns anything else, the test fails and Pester shows you the difference. This simple pattern of arrange, act, and assert forms the foundation of all your tests. Pester provides a variety of assertion operators that let you verify different types of conditions. The should-be operator performs exact equality comparison, checking if 2 values are identical. Should-be exactly is similar, but performs case-sensitive string matching, useful when case matters. Should-match uses regular expressions to check if a string matches a pattern, giving you powerful text validation capabilities. Should-contain verifies that an array includes a specific value, perfect for testing collections. Should-be null or empty checks whether a variable is null or an empty string, helpful for validation testing. Finally, should-throw verifies that a command throws an exception, which is essential for testing error handling. Each assertion can be negated by adding the not parameter, allowing you to test negative conditions as well. Understanding these assertions gives you the tools to verify virtually any behavior in your code. Once you have written your tests, you need to run them to see the results. Pester provides the invoke-pester command for this purpose. If you run invoke-pester without any parameters from your project directory, it automatically discovers and executes all test files in the current folder and subfolders. By convention, test files should end with .tests.ps1, which helps Pester identify them. If you want to run a specific test file instead of all tests, use the path parameter. Invoke-pester-path followed by the file path, such as ./myfunction.tests.ps1. When tests run, Pester displays the results in your console, showing you which tests passed, which failed, and providing details about any failures. This immediate feedback helps you quickly identify and fix problems in your code. As your test suite grows, proper organization becomes increasingly important. Pester provides the context block to help you group related test scenarios within a describe block. While describe typically represents a function or feature, context represents different conditions or scenarios under which that feature operates. For example, when testing a get-user function, you might have one context block for when the user exists and another for when the user does not exist. Each context can contain multiple it blocks testing different aspects of that scenario. This creates a three-level hierarchy: describe for the feature, context for the scenario, and it for the specific test. Using descriptive names for your context blocks makes it clear what conditions each test is examining. This organization not only makes your tests easier to understand, but also produces more readable test output, helping you quickly identify which scenarios are failing. Many tests require some setup before they run or clean up afterward. Pester provides BeforeAll and AfterAll blocks to handle this. BeforeAll runs once before any tests in its scope execute, making it perfect for expensive setup operations like creating test databases, establishing network connections, or generating test data files. AfterAll runs once after all tests in its scope complete, ideal for cleanup tasks like removing test files, closing connections, or restoring system state. These blocks ensure your tests run in a consistent environment and do not leave artifacts behind. You can place BeforeAll and AfterAll blocks inside describe or context blocks, and they will only affect tests within that scope. There are also beforeach and aftereach blocks that run before and after each individual test, useful when every test needs a fresh environment. Proper use of these setup and teardown blocks keeps your tests reliable and independent. Following best practices helps you build a maintainable and effective test suite. Always name your test files with the .tests.ps1 extension so Pester can discover them automatically. Each it block should test only one specific behavior or condition. Testing multiple things in a single it block makes failures harder to diagnose and understand. Keep your tests independent and isolated from each other. One test should never depend on another test running first or modifying shared state. This independence ensures tests can run in any order and remain reliable. Run your tests frequently during development, not just at the end. This practice helps you catch bugs immediately when they are introduced, making them easier to fix. Finally, use descriptive names for your describe, context, and it blocks that clearly explain what is being tested and what the expected behavior is. Good names make your tests serve as living documentation for your code. By following these practices, you will create a robust test suite that gives you confidence in your PowerShell code.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.